Okay, so if they ask you the derivation of this one, sine alpha plus beta, to show that this is equal to sine alpha cos beta plus cos alpha sine beta. Okay, so for this one, to show that that's what it's equal to, you can start by saying make sine alpha plus beta, make it cos 90 minus alpha plus beta. Okay, so what do we use there? Co-ratios. Remember co-ratio says that sine x is equal to cos 90 minus x. Okay, that's also from grade 11. Sine x is cos 90 minus x. So we just changed the sine alpha plus beta to cos 90 minus alpha plus beta. And now this next step is a little bit of a difficult step. Now you say, make it 90. Obviously, if you multiply the negative thing, it's going to be 90 minus alpha. Okay, 90 minus alpha. And then the minus times the beta gives you minus beta. Okay, that's not difficult. We just said, multiply the negative thing. But now we just say, you don't change anything. You just say, let's just put brackets around these two. I can do that. Because there's nothing in front of it. There's nothing behind it. So I can just say, I'm putting brackets around because I want to see this as one angle. Okay, so that's what you do. You first just multiply the negative thing and say, okay, let's just put this one as one angle, 90 minus alpha. Okay, why? Because I want an angle minus an angle. Now we're back to, if you think of this as an angle, okay, then we're back to what we did in the beginning. Cos, let's say cos x minus beta. Okay, if you think of this as one angle, what would happen if this was cos x minus beta? It would have been cos x minus beta is cos x cos beta plus sine x sine beta. Okay, from that first compound angle we looked at. Okay, let's just write it down here. Cos x, let's make it x, cos x cos beta, okay, plus sine x sine beta. That's what cos x minus beta would have been. Cos x minus beta. Okay, from our first identity. Okay, the first identity is that cos x minus beta is cos x cos beta plus sine x sine beta. Okay? So you can say, imagine this is like your x minus beta. Then you knew you can use now this identity. But what is it now? It's not x, it is 90 minus alpha. So you're not going to put x in here, you're going to put this angle in there. This is an angle, 90 minus alpha. So the x becomes 90 minus alpha here, and the x becomes 90 minus alpha there. Okay, so you basically just substitute it with 90 minus alpha. I can actually write it here, cos 90 minus alpha, 90 minus alpha, and here make the x, let's just make it small, 90 minus alpha, and that's going to be sine. Okay, so we just substitute the x with a 90 minus alpha, 90 minus alpha, and then obviously here, you don't even have to write this part down. Okay. It's just to help you understand from how to go from there to there. Also, you don't need to write that down. It's just to help you understand. So now we can say, okay, this is a co-ratio. Cos 90 minus alpha is sine alpha, and then you still write the cos beta, and then sine 90 minus alpha is cos alpha. So it's a co-ratio. It's cos alpha sine beta. So you see sine alpha cos beta plus cos alpha sine beta. So we showed that this is equal to this. We started with changing to a co-ratio, changing to cos, then multiply negative in, putting this as an angle, write the angle, and then just change using the co-ratios. Change those when you use the co-ratios. Okay. So the important step is from here maybe to there. Understanding that this is an angle minus an angle. So cos alpha minus beta, we know what that is. And I can write that down, but then instead of saying alpha minus beta, or alpha and beta, I just use this as my angle. 90 minus alpha is my one angle, beta is my other angle.